All right, question 2, part C. Willow has to choose between 2 ramps to ride her bike up to the top of an incline. It takes less time to use ramp B. Is the work needed to get to the top of ramp A more, less, or the same as the work needed to get to the top of ramp B? Explain your answer. All right, so first of all, let's just write down what the equation for work is. Work is equal to force times distance. All right, so when we're looking at work, we're looking at the distance we're going from. So we're going from the ground up 0.5 meters for both of these. Now, because that distance that we're going up is the same, don't worry about the horizontal distance. We're just looking at the vertical distance. Because that distance is the same, that means work is going to be the same. Just because you're taking a longer sort of time to get up something doesn't necessarily mean that you're doing more work. You're just sort of expending that over a longer period of time, or over sort of a ramp or an incline. That's why we use ramps. So what the work is the same to get from 0 to 0.5 meters for both of these. So we're going to write that. So as they are the same height above the ground, the work required for A will be the same as work for B. So work A is equal to work B. All right, so this kind of rolls into part 2 here. Explain how the 2 different ramps differ in terms of the force and power needed to ride up them. Calculations aren't required. Okay, so let's talk about power first of all. So power is equal to work over time. So something that is more powerful, you'll be able to do work in a sort of a lower amount of time. Something that is less powerful, it takes you longer to do the same amount of work. So it already told you at the beginning of this, Willow says that it takes less time to use ramp B. So in terms of power, less power is required to go up ramp A. Less power is required, or used, probably used is a better word for that, to go up ramp A. So therefore more for B, as it takes a longer amount of time. Work is equal for both A and B. So only time impacts power in this instance. Okay, so more power is required for B. All right, so that's power done. Right, now the next one is force. So what's the difference between the amount of force that is required for A and B? All right, so we've already acknowledged that the amount of work that needs to be done for ramp A and ramp B is going to be equal. So we know that work for A is equal to work for B. And work is calculated by saying force over distance. Force over distance. All right, so we know now because we're actually going up the ramp, we're going to now consider that the horizontal force is here. So what is the horizontal force that is required here? Sorry, the horizontal distances here. So to go up ramp A, you have to travel a longer amount. So, 3 meters is the length of the ramp on the base, whereas the ramp on B is only 2 meters long. So even though you're using the same amount of work to go up it, that's being exerted in a different way. So for work A to be equal to work B, you need to actually use more force in work B for that to even out. It's all kind of about ratios. So we're just going to explain that really quickly, that as work is the same, but greater distance required